Hey guys, Professor Doney back. We're talking about waves on a string. This is problem number 2, and what we're looking at is essentially a guitar string or bass string or a string on a piano or any other stringed instrument where it's held between two points where it's going to vibrate over, or fulcrums. For a guitar, this is where the tuners would go, and you'd spin the tuners to tighten or loosen this, and then this would be connected into the body. But what we have is the length here in green that would vibrate. If we pluck this, we just take our finger, or we take a plectrum or pick, as guitarists and bassists would call it, and pluck that and get it to move. It would move this way. It'd have an amplitude up, an amplitude down. We could call that plus and minus, or just amplitude. So that would be at the center. So it would give us this. Now essentially what that's giving us, though, is just a single or half a wavelength there, right? That's not giving us an entire wavelength, because an entire wavelength is this. This is only giving us that first part, as we saw in the previous problem. And what we're going to say is, if we pluck that string, let's say it gives us an A note, and an A note is going to be at 440 hertz. Okay, I have a little issue here with my pen. Hello. There we go. Now I want to know, if I shorten it, right? By shortening it, what happens? I get it. If here's the string now, let's shorten it by a certain length. The wave only fits on that portion, or only vibrates between those 2 points. If the wavelength goes down because of the wave equation, the result is the frequency has to go up, and that's what we're looking to do here. We want it to go up to 600. So we want to know where to put a finger, or where to restrict it or shorten it, or by how much length to make it to go from the 440 to a higher frequency. So to go higher frequency, to have this number go up, we have to reduce or shorten that. And that's how stringed instruments work. As you shorten a string, whether with your finger or by physically shortening it, like in a piano where you have many strings, you're going to adjust the frequency one way or the other. So how do we solve this? Well, here's the deal. We know on the first string, before it's shortened, we have a certain velocity that's based on the tension, mass per unit length, that square root equation. Now if we don't touch anything about the string, we don't tighten it coming up here, the tuners, we don't put a different string on or heavier string, that velocity in the first one has to equal the velocity in the second, because it's still the same string. Okay, that's what that says there, even though I know, should have been a doctor. So velocity is there. So velocity 1 has to equal velocity 2 because we didn't change it. That means wavelength 1, frequency 1 has to equal wavelength 2, frequency 2. Now, the wavelength of the first one, we could just change that, since the wavelength is twice that in both of them, we could just change that to be 2L. Frequency 1 has to equal 2L2, frequency 2. Alright. And if we do that, we can start cleaning things up a little bit. We can get rid of the 2's. Alright, the length of the first one is going to be, I think we said 1 meter. The frequency of the first is a 440. The length of the second one, don't know, but the frequency 1 is 600. So if we go through and solve this, do this quickly before we run out of time. 440 divided by 600, it's going to give us 0.73 meters. Now what that means is, I want to adjust this length, or I probably, for a guitar, since we're picking on this end, we'd be adjusting it on that end with our finger, but we want to shorten this, so this is now only 0.73 meters long. And if we do that, we will get a 600 hertz frequency, or note, or tone. So if you're into guitars or stringed instruments, that's where they have the frets. It's forcing it to now vibrate over a shorter length. The string gets tightened here, you push it down, now it vibrates between these 2 points. Here and here we have a shorter length, the frequency goes up, and that's what we want. So everybody is happy. Alright, hope that works. See you in the next video.